Okay. Well, first of all, I would like to thank to the committee to accept the proposal that we have been on the paper proposed. So thank you so much. This is a joint work done with MSI Group, which is Mondragón Sistemas de la Información. I don't know if somebody speaks Spanish in this room. And Mondragón Universitatea. Let me introduce what we have done, right? So we are talking about how to avoid attacks and how to avoid problems in the industrial field, specifically in the water systems. All these problems come from the well-known student attacks. I'm pretty sure that everybody has seen this slide before and everybody knows what I'm talking about. So basically, like 10 years ago, it was a nuclear program in Iran, so it was a lot of news in the newspapers saying that Ahmadinejad wants to develop nuclear weapons. It seems that some government has deployed a solution, a cyber-physical attack, in order to stop the industrial processes. So this is a well-known and reported attack, which is it's a job done by Wagner. And basically what we have seen is he starts the work that the people is doing today. We are seeing the same. So people is using IT attacks to deploy a malware, a virus in the network, but they are targeting OT systems. So the same philosophy is still used today, right? So people is trying to get the ICS devices by using the IT techniques, and once they are in the OT field, they start to stop or they start to do bad things in the ICS projects. So the same philosophy is still repeated today. Why this is a problem now? So as you know, as everybody know, now we are involved in an age of the digital transformation, right? That's the reason because there is this event here, Basque industry. So what we are doing is we are involved in the Industrial 4.0 revolution, which basically means that we want to connect the processes, the industrial processes that we have today, the factories, to the internet, and take advantage and leverage on the new IT techniques and the new IT technologies. So basically what we want to do is what we have done like 20 years ago in the office, when we are using new papers and we start to use computers, we want to repeat the same process with these industrial systems. And what is the problem? So when we are trying to apply and when we are trying to develop the solutions, the IT solutions in the OT field, there is some problems done by design. The biggest problem is that the lifetime of the machines are much higher in industrial processes than the IT processes. For instance, in a production line, the lifetime of the machines could be 20 years, up to 20 years, maybe even 30 years. However, in an office, you're changing the computers in 3 years, 5 years, and also it's no problem if somebody is giving you an iPhone, right? It's a year, so it's okay for you. So that's a huge problem in the OT world because we cannot apply the same techniques that we are doing in the IT. Additionally, it's really difficult to update the systems. Typically, if you are in the IT field, you can have automatic updates of your operative system. That doesn't work in the OT world. You cannot update the operative systems of the machines, right? That's the reason because maybe you have Windows Vista, Windows XP in the production lines. Because somebody has deployed the solution, they have a maintenance agreement, and they cannot change it. It's not about the technology, it's about the papers and the bureaucracy. You cannot change that. So, additionally, the criteria for the solutions also change. When you are in the IT field, the most important criteria is privacy because you are sending personal data through the internet or through the network. However, if you are in an industrial system, the first priority is availability. You never ever have to stop the production. Even you are suffering an attack, right? So nobody cares if there is an attack. The most important thing is production because it's the metric that my boss is measuring me. If I do not produce, I get fired. Okay, doesn't matter if there is a cyber attack. It's not in my pocket. It's not my problem. So, okay. just going into the point, is this important? So do we care? It's really somebody attacking these industrial systems? The answer is yes. So giving those, this is data from Kaspersky, which is saying that the 30% of the ICS systems in Europe has been targeted the half time of 2 years ago. And this is also important, the following data from INCIBE, which is the Spanish Cybersecurity Institute, which is telling to us that those attacks are targeting vulnerabilities of the systems. This means that they are targeted attacks. This is not a phishing attack, so it's not body doing a spam and just phishing some victim. It's people who is targeting the attack and wants to make something wrong in the specific device. That's a problem. We have recently, it's a paper from this year, there is a review for cybersecurity incidents, and it's exploring the 15 incidents in water segment. Which is important from this table. I will be happy to share the reference because it's really easy to read and it's quite nice. They have a review of how the systems have been targeted, who has attacked these systems, and which kind of attacks you have suffered. Which is important for the system, for this report, is that it's telling us which are the domains that we have seen the attack and which are the capabilities of the attacker. This is highly remarkable because we can find surprising news. For instance, in this report, most of the attack, well, 1/3 of the attacks comes from accidents. So maybe it's an insider or it's people who is doing something bad, but he doesn't know about that. Also, 1/3 of the attacks comes from criminals, not governments, criminals. Somebody who wants to take a money advantage, right? Some financial advantage. And which is also interesting from this attack is where the people is attacking. Most of the attacks go to the OT, not the IT. We are typically thinking that people is targeting the IT systems. However, the review was just saying that they are targeting the OT, right? So this is important. It's counterintuitive. Going to the specifics of our use case. So we are deployed a solution in a generic water system. The water system has, is provided by Mondragon, and what we have done is we have evolved the security of this plant, targeting the different levels of cybersecurity. I will explain you who are these levels. So the first cybersecurity level prevents accidents. So it's people who maybe is on Monday, he has a bad day, and just stop a machine and he don't want to do it. Okay, that's a problem, that's a failure in security. It's the same kind of problem if you don't put your belt in your car, right? So you have to put the safety belt. So you also have to take care of these accidents in cybersecurity, even in the OT level. So it's really basic. This security level covers non-intentional errors, people who has not resources, and also has not intention. It's a pure accident. As you can see, you have 14 criteria and 14 requirements in the standard. The standard is called IAC 62443. Maybe you know about it. Most of the people, I think, that knows what I'm talking about. So these requirements in the first level, for instance, cover things like the Wi-Fi. You need to have authenticated Wi-Fi, right? You also need to have segmentation. You also need to protect a kind of firewalling or protect the data in transit and information at rest and have backups. It's really basic, but you need to do it. The second level covers the hackers or the cyber criminals. So it's people who have some motivation. But they have limited resources, right? So it's maybe one individual that wants to do something bad to your infrastructure. Could be a competitor or could be an insider that wants to stop your infrastructure. That's really important because maybe the motivation is not to hide, but he can do something wrong in your system if he knows, for example, some commands of Kali Linux. So that's enough. In order to cover these potential attacks, you have to take care of these 11 requirements. In green, we are showing the solutions, the requirements that are covered by our solution. Finally, I would like to talk about the security level 3. This level covers against terrorists and organized groups of hackers. So these people has some resources. When I say some resources, is that it's a group of people. So he puts his time, his motivation, and he wants to stop something. And they used to be some kind of finance, right? Because they need to, it's a group of people, they need to be fit, right? So there's some money in his pocket. So it's somebody paying them to do something bad. Indeed, think on the following, they are professionals. So they have some knowledge about what they are doing, and they have some knowledge about the specific ICS systems, right? In order to cover this tier level, you also need to add to the previous 25 requirements those 12 requirements, right? So, it's growing over and over. So going to the details. So that's a typical architecture that you can have in the water plan. You have the SCADA system with engineering stations, some servers, and then you have PLCs that controls maybe some quality, water quality processes, etc. And you have the sensors on the gateway. In order to protect that, the first of all that you have to do is to make a segmentation of the network. And well, the very first step is to do a plan, right? Typically, that's the ICS customer roadmap. So the first step, you have to hire somebody to help you to do a security plan. Then you have the security plan, you have to start to implement different solutions, such as asset inventory. You need to know how much assets you have in your network in order to know your vulnerabilities. Once you know that, you can make the segmentation of the network, put the rules of the communication in between the devices, and finally, once everything is done, you need to mitigate potential vulnerabilities and monitorize the network. In order to monitorize the network, you used to, let's say, use a contractor, right? Because it's cheaper for you, and then you need to communicate these systems to a SOC. So why this is a problem today? Why not everybody is cyber-securing the OT plan? Because in most of the cases, doing a segmentation is really easy in IT, but it takes months in OT. Why? Remember that the legacy systems, the infrastructures have a long lifetime, right? This means that your devices typically do not support VLAN, so you cannot use easy solutions for segmentation. So your project that in segmentation takes weeks in IT takes months in OT, because you also cannot stop the plan. Additionally, you have further problems. Do we have time? Come on. Yes. Mitad. Vale. So let me explain what happens when your network is not secure in OT. So assume that, for instance, there is some maintenance contractor. That's a vector attack, right? You have to take care of the following. What happens if somebody goes with a laptop to do some maintenance and he has a ransomware, for instance? Then typically what the attackers do is the following. First of all, they scan the OT plan and learns about your vulnerabilities. And once he knows your vulnerabilities, they do some exploits and stop your system. That's a huge problem. So in order to do that, you need to, for instance, apply segmentation, avoid that these people can do the attacks, or encrypt the network. There is another kind of vector attacks, like the USBs. So if somebody gains access to the plan, maybe he doesn't know how to do it, but he infects some HMI, and then the propagation of the ransomware can be spread through the network. You need to apply some kind of firewalling techniques to do that, right? Additionally, sometimes if there is advanced attack, people can to gain access through the OT network to the IT network, and then send some bad commands and make a command and control attack. So in order to avoid that, you also need to use firewalling and segmentation techniques. Going back to our architecture, how we protect that, which is the specific use case. So what we have done is we have deployed our solution, or boxes, which are completely transparent to the network. And then we do the zone segmentation, right? In that case, you are protecting that if somebody is gaining access in one of those zones, he cannot have access to the other zones. So you are preventing and authenticating the potential problems. After that, you have to define the conduits. So you have to say who can communicate with who, which are the zones that can communicate with the others, and which protocols can be used. And then you are, let's say, you are hardening these zones, right? Finally, you will need to check that how I know that if I have a zone which is secure, how I can track, how can I monitor that somebody who is plugging into this zone is not spreading some malware. So you have to monitorize the network and see which are the devices connected inside the zone, right? And that's all. Basically, what we have done with Mondragon and MSI is the solution. I don't know if you have some questions. Okay, cool. Thank you.
Thank you so much.